Welcome to section 6.1, Roots and Radical Expressions. The first thing I'm going to show you is a symbol. This symbol is called the radical symbol, and it's used for taking different roots, square root, cube root, etc., etc. Symbol. Okay, now there's different symbols that are used when you, like on a, well, not a typewriter, but on a computer. Like, for example, this symbol right here is called the exclamation point. This symbol is called the caret key. So different symbols have different names to them. The one used for email, the @ symbol. All right. So all of these are different types of symbols. Well, this one here is called the radical symbol. Now the name of it changes when you put numbers with it. So for example, if I put a 25 here with the radical symbol, then that means square root. So now it's called the square root symbol, and the square root of 25 is 5. Now if you change the little number out here, you're changing something called the index. So if you have the cube root of 8, so now there's a 3 there. So it's the radical symbol with a 3 and a number, so that means cube root. So the cube root of 8 is equal to 2. All right, and then let's see, 620, well, let's do 256. The fourth root of 256. The fourth root of 256 is equal to 4. So that's called the fourth root because there's a 4 there. And if there's a 5, it'd be fifth root or whatever. So these numbers that are changing right here, this is called the index. All right, and this is square root, cube root. I'll write this out. Square root. So that's the square root symbol now. Then with the 3 there, it'd be cube root. And then with the 4 there, we call it fourth root, etc., fifth root, on and on and on. So by changing the index, you're changing the name of that radical symbol. So if there's nothing there, it's square root. If there's a 3 there, it's cube root. If there's a 4 root there, it's fourth root, etc. Now, where are these numbers coming from? They're all coming from the yellow paper, pink paper, whatever your colored paper is. So here, see, there's 256. So 4 to the 4th power is equal to 256. That was one thing we did. 25. 5 to the 2nd power is 25. And what was the other one? 8. 8. 2 to the 3rd power is 8. Okay, so there's a relationship here. 5 to the 2nd power is equal to 25. That's the connection between this and this. 2 to the 3rd power is equal to 8. So 2 to the 3rd power is 8. That's the connection between what's on your colored paper and this index situation with the radical symbol. And then 4 to the 4th power would be equal to 256. So that's 4 times 4, which is 16. And then another 4 times 4 would be 16. And 16 times 16 is 256. So that's the connection here. 4 to the 4th power, 256. 2 to the 3rd power is 8. 5. No, you could say there's an invisible 2 there. 2 to the 2nd power is equal to 25. Now, one of my favorite relationships on this colored paper is the 7,776. So I call that America plus 6,000. Get it? It's America and then 6,000 more. So that would be 6 to the 5th power is equal to 7,776. So that's 6 times 6 times 6 times 6 times 6. I think I said 5 of them. And to prove that to you, I'll go to the calculator here. And we'll say 6 to the power of 5 is equal to 7,776, which is 6 times 6 times 6 times 6 times 6. There we go. So then you could turn this into one of these index things with the radical symbol and all that business. So it would be the 5th root of 7,776, and that would be equal to 6. So what you're doing every time is you're looking for the base. Remember, this is called the base, and then this is called the exponent. So what you're looking for is you're looking for the base. So this index is like the exponent down here, and this index is like the exponent here, and this index of 5 is like the exponent over there. So you're looking for what number makes this happen. Okay, so we've learned that this is called the radical symbol, just like there's symbols on a keyboard of a not calculator, but a computer, square root or exclamation point, caret key, at symbol, brackets. I mean, they all have different names to them. You know, less than, greater than. These are all symbols, but this one happens to be called the radical symbol, and it's for doing roots. So roots, and then radical expressions. We're going to do a radical expression here in a minute. Okay, so this one here doesn't have any number there, and there's no index, so it's just square root. So we just take the square root. All of these examples are simplified. So example, we can call this example 1a, and then b, c, etc. So the square root of 25 over 49 is just what it is. This is the square root of 25 over 49. So I just take the square root of 25, take the square root of the numerator, take the square root of the denominator. So it'd be 5, and then the square root of 49, of course, is 7. The next one is cube root of 729. So I like to go off of the colored paper instead of going off of your calculator, because I want you to understand the relationship between these. So we want cube root, so we look in the cube column, and you go down. Oh, there's 729. So what number is helping this happen? Oh, it's 9. It's 9 happening 3 times. So it's 9 times 9 is 81, times 9 is 729. So therefore, the answer is 9. 9 to the third power is 729. The next one is, the next one's a little bit trickier. We're going to say this the proper way and change it into a fraction. So it's the cube root. Remember, the 3 means cube root, and it's tenths, hundredths, thousandths. So it's 27 thousandths, or 27 over 1,000. And then I can just go ahead and take the cube root. So the cube root of 27, so if you look here in the cube column, there's 27. The cube root of 27 is 3. And then the cube root of 1,000 is 10. So that's how you read it. You go to the cube column, you find the numbers, and you look over here. And these are all the bases. So if you want to write base right here, these are all the bases. So this would be 3, because 3 times 3 times 3 makes 27. And this would be 10. 10 times 10 times 10 is 1,000. Now if you did this on a calculator, you would get 0.3, which is the same thing as 3/10, because that's the proper way to say 0.3. That's kind of the lazy way to say it. It's 3/10, because that's that decimal point. So remember, it's tenths, hundredths, thousandths. So it's 27 thousandths. Take the cube root. Okay, that's examples A, B, and C. Now we're going to go with example D. Example D is the square root. Now, the name of the section was radical expressions. So roots and radical expressions. So what we've been doing right now is roots, but this is considered a radical expression because it has algebra with the radical. By algebra, I mean there's a variable right there. It's a to the 6th power. So we go through and we have to figure out how do we deal with this. Well, I kind of told you how to deal with the numbers, but how do you deal with the this 6 here? How do you square root of 6? So the first thing we do is we just take the square root of 25, because the square root of 25 is just 5. But we have to say to ourselves, what times what makes 25? Well, that's 5, but what times what makes this? Well, a to the, remember when you multiply like bases, you add the exponent situations, it'd be a to the 3rd, right? Because a to the 3rd times a to the 3rd is equal to a to the 6th. When you multiply like bases, you add the exponents. So it makes sense that the square root of this would just be one of those. So there we go. There's the answer. That's partially the answer. Another thing that we can do is the invisible index out here is 2. Remember, when there's no index, it's 2. So you can take the 6, and then you can look at this 2. So if you have 6 and 2, and then you look at 3 right there, it's like, what's the relationship between 6, 2, and 3? Oh, yeah, 2 times 3 is 6, or 6 divided by by the number out here is equal to 3. So I like to sing a little song with this. I call this the exponent, right? And this right here is the index. So what you do is you take the exponent and you divide it by the index. So it's e over I. That's where this is coming from. You take the exponent and divide it by the index. So all the students know the exponents e, I. Oh my gosh, I get it. So it's 6 divided by 2 is equal to the 3. And then the square root of 25 is just 5. The other thing we need to go over is a situation, I call it the even odd rule. The even odd rule says that if you have an even index, an even exponent, and an odd answer, you have to add absolute value around that. So the answer really is 5a to the third power. That's really the answer here. So, and it's the absolute value of a to the third power. So what's happening is anytime there's an even index, an even exponent, and an odd result, we add absolute value. So that seems really weird, but we've kind of been doing this the whole time. When you have x squared equals 25, this is an aside, how do you solve this? Well, you take the square root of each side of the equation. And I keep saying, hey, you need to not forget the plus or minus. Well, what's really going on here is this is an even, odd situation because it's an even, and then it's x is the answer. Well, that really needs absolute value. And the square root of 25 is just 5. But then the absolute value here requires 2 answers. So the plus minus is not coming so much from here, it's coming from this absolute value idea. So the answer is plus or minus 5. Because plus or minus 5, the absolute value of that is just 5. So that's what's going on. It's an even, odd situation. You add absolute value, and then it's 2 solutions, plus or minus. So 2 answers can make this true. A positive answer or a negative answer basically is what's going on here. So now we're going to do the last example. So to be absolutely clear, it's 5a to the third with the absolute value. That's the answer to this. So take the square root, cut this in half, add the absolute value. So here we go. So 4, this is p to the 12th, q to the 4th with a 4th root. So 12 divided by 4 is 3, so it's p to the 3rd. And 4 divided by 4 is 1. So you can put a 1 there or not put a 1 there. So does it follow the even, odd rule? Even, odd, yes. Even, odd, yes. So both of them fall inside the absolute value. All right. Now, if one of these, well, if that was an 8, then you would only put the absolute value on this one. So if it was p to the 12th and q to the 8th, and then it was the 4th root, it'd be p to the 3rd, q, 8 divided by 4 is 2. So you'd only put the absolute value around this guy, not that one. So it has to be even, odd, not even. Okay, so anytime you have an even root here, you have to watch out for this even, odd rule.